Hello everyone. So for my weka challenge, I use the dataset from UCI repository. These datasets are already in .arff format, which are supported by weka, so I don't need to convert it from .csv format. This is the dataset I choose, which is about the basketball statistics. As you can see, there are 5 attributes: assists per minute, height, template, age, and points per minute. All these attributes are numerical. Use 3 methods to analyze this dataset: regression, classification, and clustering. So first, I will start with the regression. Here, I will open the functions and choose linear regressions and click Start. As you can see, there are 2 variables that have impact on our dependent variable, the points per minute. One is the assist per minute and another is the template. As you can see, the assist per minute have a negative correlation with the points per minute. This is understandable because if you assist more, you don't have opportunity to get the point. Right now, the correlation coefficient is about 0.61, but we don't know if the height and age will affect the points per minute. So let's go back to the dataset and remove the assist per minute, and then redo the linear regression. You can see heights appear here if we remove the assist per minute, but the correlation coefficient goes down. So we can say the assist per minute has stronger correlation with the points per minute than heights. The next method I use is the classification. So let me just go back to dataset and undo to recover the assist per minute. Then go to the classify. So my initial idea is to choose the J48 from the weka tutorial in last week's slides. But since all the attributes are numeric instead of categorical in this basketball dataset, so I can choose J48 here. Instead, I decided to choose a random tree. And let's start. As you can see, the correlation coefficient is really low. If we visualize the tree, you can see like the dataset is really messed up. So let's go back and make some changes about the decision tree. So here I will change the minimum num from 1 to 5. So the minimum total weight of the instances in a leaf will be 5. Let's click OK. I restart it. So if I visualize tree again, you can see this tree is more clear than before. As you can see, the correlation coefficient increase from 0.28 to 0.37 if we change the min num from 1 to 5. However, the random tree is not in deep machine learning comparing to J48, so this is just a reference. So if you check the tree, you can see it still somehow determines the output of a new data instance, but the correlation coefficient is pretty low, it's below 50%, which means this is not a perfect model. I guess one of the reasons could be there's no categorical attributes in this dataset, only numerical data. So we can simply divide the dataset by yes or no or some categories. The last method for my weka challenge is clustering. Clustering is to use patterns to determine different group of data and make conclusions. So let's go to cluster and choose simple k-means. It took me several times to find an ideal number of clusters. And finally, I found 3 clusters would be the best one. So let's click OK and start. There are 3 clusters and each one has its own pattern. The first group is players who have few play time. Obviously, their points per minute would be below average since they didn't have many opportunities to play. The second group shows players who have plenty of time to play and less assists per minute. It means they focus to get points in the game, and that's why they have the highest points per game among all 3 clusters. The third group are players who also have plenty of time to play, but they focus on assisting in the game. As you can see, their assists per minute is above average, so their points per minute will be lower, considering the negative correlation between points per minute and average per minute. That's all I've done for my weka challenge. So one question I had was that is there any method to improve the accuracy of the decision tree for numerical data? Is there any other choice besides using random tree? So I think I will do further research on this topic and try to find some other methods. Please let me know if you have questions on my weka challenge. Thank you.